Hiya, Mary McIntyre here. It's the 11th of May, which means we are heading towards Noctilucent Cloud season, one of my favourite times of the year. If you've never seen Noctilucent Clouds before, this video will be helpful to you, I hope. I'm going to kind of talk you through the basics of what they are and how you can see them and where you can see them, and a little bit about them. But if you want more detail, I've written a much more in-depth blog, which I will link in the description box below. So I'm going to just kind of tell you a couple of things about these clouds. They are so unbelievably beautiful, and anyone who knows me knows I do not do mornings. I really hate mornings and getting up with an alarm, but I will happily set my alarm for 2 a.m. if I think I'm going to get something like this when I go out. They're just, no two displays are ever quite the same. They've got this absolutely beautiful, ethereal, glowing quality about them. The name Noctilucent translates as night shining, and that's exactly what they do. They kind of shine out through the twilight. And if you're not sure whether you've seen them, the chances are you haven't, because once you have, you don't forget it. They're just so, so beautiful. They're slightly mysterious because until 1885, they'd never been reported. And people back in history were very, very good meteorologists, and a lot of stuff was reported and recorded and studied and analysed. So if they'd happened before then, there's a good chance somebody would have written it down. So something happened around then that meant that they started to form. They used to be quite rare, but now they're happening more frequently. And I'll talk a couple of the reasons why that might be. Now, these are a type of mesospheric cloud, polar mesospheric clouds, and that means that these clouds accumulate around the polar regions at a very, very high altitude. And I'll talk about the altitude in a moment. And basically, this happens during the summer months. So in the southern hemisphere, I'm specifically today talking about the northern, but in the southern hemisphere during your summer months, you'll have the same thing around the South Pole. But for us here in the UK, from mid-August through to mid-May, to kind of mid-August time, that is when you get this accumulation around the North Pole of these clouds. And they're kind of rotating around, and they form these kind of arms, which are called petals. This is called the Noctilucent Cloud daisy. And these pictures are taken by a satellite that's actually in orbit around them. Basically, they are really, really high. So these clouds are very different from other clouds that we might see in the lower levels of the atmosphere. So just to put this into some context, fluffy, puffy cumulus clouds are only kind of 2 kilometers above sea level. Cirrostratus clouds, they're the ones responsible for atmospheric optical effects like ice halos, sundogs, all of those types of arcs and stuff like that. That is an entire talk that I do separately. But those are the highest clouds aside from big towering thunderclouds, but excluding those sorts of thunderclouds, cirrostratus clouds are the highest at 6 kilometers up. Noctilucent clouds are so much higher than that. If we go up through the layers of the atmosphere, through the stratosphere, through the mesosphere, and up to the boundary between the mesosphere and the thermosphere, that is where noctilucent clouds reside. So this is kind of 80, 85 kilometers above sea level that they're at. Aurora is only 15 kilometers higher than that. So they really are up on the edge of space. Now, because they form in the mesosphere, there's quite a few things that need to be like the correct conditions for it to happen. And the mesosphere, first of all, has to be below minus 123 degrees Celsius. That only happens when the lower levels of the atmosphere are warmer. So when the troposphere and the stratosphere get warm, the mesosphere cools down. So that is why we only see them during the summer months. So that's one reason. We also need a water source, and the mesosphere is actually very, very dry. So you don't get noctilucent clouds every day because there isn't always a source of water there. And the amount of water that's there is actually linked a little bit to solar activity, because the more UV that bombards the atmosphere, as well as breaking down oxygen into the ozone layer, any water that's around in those higher levels of the atmosphere will be broken down and just removed, so there won't be any water for those crystals to form. But as well as that, there needs to be some kind of nuclei that's a catalyst for the ice crystal forming in the first place. And 2 years before the noctilucent clouds were very first sighted, there'd been a big eruption at Mount Krakatoa. So for years, people were thinking that volcanic ash, really small particles of volcanic ash, could be the seed that started this ice formation. We now think it could be micrometeorite dust, but really we don't know for sure. It could be both. But one thing that is for sure is that they're no longer rare. We're seeing them more and more, and probably the most likely cause for that is the increase in greenhouse gases that we've been pumping into the atmosphere since the late 1800s, because, as I said, the lower levels being warmer will make the mesosphere cool down. So I think climate change is definitely one impact there as the reason why we're seeing them more often. And as I said, they're more active during solar minimum. Now, the other thing that makes these clouds very different from any other clouds is the size of the ice crystals. To give you some context, this is an actual photograph of cirrostratus cloud ice crystals. It was sampled, and this photograph was by Walter Tape. I have no idea how he did this, but those kind of atmospheric optics crystals, they're mostly hexagonal ice crystals that are refracting light and causing dispersion, and you get beautiful colored halos and all of that stuff. And these crystals are around about 0.1 millimeters in size. So this entire panel here is somewhere around 1.5 millimeters. So these are pretty small ice crystals, and there are millions of them within the clouds, many, many millions of them. To scale, this is actually the size of a Noctilucent Cloud ice crystal. So you can see it's significantly smaller by about many, many times. And this is 0.1 microns across. So they are absolutely minute. And that is the main reason that they're not seen during the day, because these ice crystals are so tiny that they don't reflect enough sunlight for the clouds to be bright enough to compete with the atmosphere in sunlight, essentially. So yeah, they're really, really tiny. Sometimes when you get Noctilucent Cloud, you get a lot of accumulation. Sometimes you don't get very much. But the crucial thing for being able to see them is that in the Northern Hemisphere, you need the sun to be between 6 and 16 degrees below the horizon. And to get that, you need to be somewhere around 50 to 65 degrees latitude. So I'm kind of bang in the middle there at 52 degrees latitude. Any further north than that, you basically don't get enough shadow on the lower levels of the atmosphere. What's happening here is that when the sun dips down 6 to 16 degrees below the horizon, all of the lower levels of the atmosphere are in shadow. But because these clouds are so high, they're still being illuminated from underneath by sunlight, which is what makes them kind of really pop and really glow. If you're further north than that, the sun doesn't get low enough below the horizon to actually cause that to happen. So being further north in Scotland is good, you can see more, but if you go much, much further north than that, then you start to struggle to see them at all. If you are much further south, then you're going to struggle to see them if you have a display like this one at the top, because quite often they're just very, very low, hugging the northern horizon. So they're very interesting to watch, and you never quite know what's going to happen in terms of what you're going to see. Even when you look at the daisy, you can't always tell what's going to happen. Now, from the UK, they're always low to the northern horizon, and obviously because they're illuminated by the sun, when you go out about an hour, 90 minutes after sunset, you're more likely to see them over in the kind of northwest where the sun has just set. If you catch them before dawn, then you quite often see them more towards the eastern side of the northern horizon. But during midsummer kind of solstice time, you may see them illuminated all night long. They may just go from dusk through till dawn. And sometimes there's hardly anything there. There's barely a glow. Other times the entire sky will be filled with them. So, if you have a display like I saw last year where it went all the way up to the zenith, then you will see them from a bit further south and into Europe. But generally it's kind of 50 to 65 degrees that tend to be able to see them. And what can I say about them other than they're just so, so beautiful? And sometimes they will fill over 100 degrees of horizon with Noctilucent clouds. And that's what's great. You never quite know what you're going to get. And they're just very, very interesting to look at. And this is an example where there was over 100 degrees of the horizon was absolutely full of these glowing blue clouds. They're not always blue, they're quite often a bluish white, but you can get red and sometimes green as well, which I haven't seen. But that would be difficult because from where I am, very often by the time you can see them, you're getting the kind of dawn light and underneath. But that makes for a beautiful photograph because you've got all of those colours going through the atmosphere with the clouds kind of glowing as well. This was an amazing night. This was last summer when we had Comet Neowise, and as soon as I found out Neowise was going to be in the northern sky, I was like, please let me get NLCs at the same time. And it happened just once, and later on, once the comet had moved off out of the field of view, this turned into one of the best Noctilucent Cloud displays I've ever seen as well. So it was a really memorable night, and honestly just sat crying when I took these pictures because it was just a dream come true to be able to do that. Now they can have very different forms, and I'm not going to go into the detail about all the different kinds because there are lots of different structures and kinds that you may see. And as I say, it varies from just a diffuse white glow to these really intricate patterns, sometimes wave-like patterns, sometimes like reflected water ripples. They're just lovely. And if you actually time-lapse them, they move in a very different way from anything else that's in the lower levels of the atmosphere. And they really are just gorgeous. And as I say, you'd never quite know what you're going to get. So it's just amazing to see them. I've also, if I time lapse something, I always take the data and create star trails with it. And I've done that a couple of times and had Noctilucent clouds in the bottom with star trails. So that was good fun. This picture was taken by a friend of mine who lives in Blackpool, Noctilucent Cloud stretching all the way up the sky behind the Big One roller coaster at Blackpool Pleasure Beach. Just an exquisite photograph. And I'll put Stephen's YouTube channel in the description box below. He does some phenomenal photography, so please go and check him out. All his social media handles are there, but I'll link his channel below, so go and give Stephen some love. Now, one way that these clouds are very, very difficult to actually predict, so you never really know what you're going to get. But one thing you can do is keep an eye on the daisy, and spaceweather.com will update this. Sometimes there's a couple of days delay before this is put live, but what it will do is help you spot trends. And actually, even though we're right down here, on this particular occasion, this was a night where Noctilucent Cloud was visible all the way up to above my head at the zenith. So it just shows you that an accumulation like this can be visible throughout most of your sky because of the altitude of the clouds. Generally, the displays I photographed are in this sort of region. But if you get any accumulation on this side that's pointing down towards the UK, it's worth going out and having a look. Now, because the daisy has a bit of a delay on it, it can be, a bit troublesome in terms of actually trying to find out whether something's going to happen right now. So what I tend to do is keep an eye on Twitter. There are two accounts. There's NLC Alerts and NLC Net, and also people within the NLC spotting community will use hashtag NLC Now, and they use that across all social media. So if anybody, particularly in mainland Europe that are an hour ahead of us, if anybody in those parts of the world are hashtagging NLC Now, then it's definitely worth going out and having a look yourself, because if they're getting it, there's a good chance that we will as well. And if you see any yourself, hashtag NLC Now and put your location as well, because that will help other people that are also looking for that. The other thing that's really good as well, don't forget to submit your observations to the BAA, obviously. Another thing that's really good is that there are webcams. There's a couple of networks that have webcams pointing north from mainland Europe and across the UK. And particularly, again, those that are an hour ahead of us, you can have a look at sunset and keep an eye on the webcams. If something starts to show on those webcams, you know there's a chance we're going to get something in the UK. Equally, if you set your alarm for 2 a.m. and you want to know if it's worth getting out of bed with your camera, just go onto those webcams. And if Europe's webcams have got NLC, then it's definitely worth going out and having a look. There's no guarantees that because they've got a display, you'll get one. They are a little bit fickle and very unpredictable, difficult to forecast, but boy, is it worth the effort, because I honestly think they are truly one of the most beautiful sights of the night sky. And I just feel so privileged that we live in a latitude where we're able to see them quite regularly. So I hope you found this video helpful. As I said, there is way more information about Noctilucent Clouds in the article that I've written that I will link below. And I'm just going to leave you with a little compilation of time-lapse videos of Noctilucent Clouds that I've shot in previous years.